Alrighty, so I've got the problems from Friday's review session here. These are problems I pulled off of the practice test and off of the final review. And I figured I'd just make a video working each one of them out. So here's number one. We're asked to solve the equation by using the square root property. So looking at this, I'm going to write down the problem. And let's see if I can zoom in a little bit. Alrighty, to start off with, probably want to divide both sides by 3. Remember, the goal is to get the variable, in this case the y, all by itself. So we divide both sides by 3. And that leaves us with y squared equals negative 120 divided by 3 is negative 40. And now here's where the square root property comes into play. We want to get rid of this power of 2 here, so we square root both sides. And remember, when we use a square root to solve a problem, when we introduce that square root, we got to add the plus minus in front of it. And now I'm noticing that we have a negative sign inside of this square root. So we'll pull that out as the letter I. And let's break down this square root. I like to do it like this, where I break everything down into my prime factors. I know 40 is 2 times 20, 20 is 2 times 10, 10 is 2 times 5, and we can't break it down any further than that because we've got all prime numbers. And we're looking for doubles of the same number since we're doing a square root. Well, I see we've got double 2's here, right? Double 2's, so a 2 can come to the outside. Anything that didn't have a partner, in this case the 2 and the 5, those have to stay inside the root. So 2 times 5, that's 10. So we've just broken down square root of 40 into 2 square root of 10. So our final answer here will be y equals plus or minus 2, and we had that I on the outside, square root of 10. Plus or minus 2i square root of 10. Which one does that leave us with here? 2i, looks like C in this case. Alrighty, so that was number one, using the square root property. Well, let's go to 2. Solve the equation using the quadratic formula. Alright, as always, I'll copy down the problem. I'm also going to write out the quadratic formula here. So that's negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. And most of you know I like to rewrite this out. But wherever I see a letter in the formula, I put a parentheses. And then we'll go back in and we'll fill in those parentheses with our with the numbers from our problem. So in this case, we've got 3 is A, 3 is B, and C equals negative 60. And we'll just fill those in. So B, B, A, C, and A again. So let's see, I've got a negative 3 here, plus minus, square root of, and I like to just type this inner part, not the square root, but the inner part into my calculator, just the way it looks. So parentheses 3 squared minus 4 times a times c, which is negative 60. That gives me 729 over 2 times 3, that's 6. So I've got negative 3 plus or minus. Can we do the square root of 729? Let's check it. Yeah, that's 27. So I'll just write a 27 there, all over 6. And now we've got two answers, right? We've got negative 3 plus 27 over 6, whatever that is. And we've got negative 3 minus 27 over 6. So we'll just go to our calculator here and type those in. Negative 3 plus 27 over 6 is 4. And negative 3 minus 27, negative 3 minus 27 over 6, negative 5. So we've got answers of 4 and negative 5, which is B. Moving on to number 3. Simplify the radical equation if possible. Well, so I'm going to write this in a different color, I guess. As soon as I see that I have a root equal to the same degree root, right? These are both fifth roots. I'm going to end up just dropping those roots. We don't need them. If we're saying these two sides are equal to each other, then the roots are the same, right? So whatever's inside the roots better also be equal. So we can just ignore these roots. And that leaves us with 10z plus 7 equals 7z plus 16. From here, everyone should be comfortable solving. We're trying to get our z's on one side and our numbers on the other. So I think I'll subtract 7z from the right. And that leaves us with 3z plus 7 on the left equal to 16. Let's get our 7 over there. Now we've got 3z equals, what's 16 minus 7? 9. And the last step, divide by 3. For a final answer of z equals 3, because 9 divided by 3 is 3. And it looks like that's the last answer, D there. Okay. Number 4, we're solving solving a quadratic. And I think I'm going to use factoring here. I can see the leading coefficient is 1. And I've got this degree 4 I need to keep an eye on. But my recommendation for these problems is to just do the AC method if you're comfortable with that. So we can imagine we have a leading coefficient of 1 here. And we've got to do A times C, right? So that's 1 times 32 equals a positive 32. And at this point, I'm writing factors of 32. So 1 times 32, 2 times 16, 4 times 8. And I'm making sure not to skip any. 6 doesn't work, 7 doesn't work, 8 we already got. So I think these are all the factors. Now we're looking for a set that not only multiply to give us 32, which all of these do, but they also we need to be able to add those numbers or subtract them to get a negative 18. So how can we get a negative 18? Well, I'm thinking 16 and 2. 16 and 2 if we use a -2 and a -16, right? Negative times a negative, that's a positive 32, which we need. -2 plus a -16, yeah, that's -18. So that's what we're going to do. We're going to split the middle term up using those two numbers. So instead of writing -18x squared, we're going to write -2x squared minus 16x squared. And now this is a factor by grouping problem, right? We've got 1, 2, 3, 4 terms. So we're factoring by grouping. So I'll kind of split my polynomial in half here. And we'll look at this first group. What do those have in common? I can see they both have an x squared. So maybe I'll pull out an x squared. And that'll leave us with x squared minus 2. On the right side, this group, they have a 16 in common, and since that first term is negative, I'm pulling out the negative with it, leaving us with x squared minus 2. That's a good thing. These two factors match, so that's one of our factors. And then the two pieces on the outside, those come together to form our other factor. Now remember, this whole time that we're supposed to solve this is all equal to 0. So at this point, we're using the zero factor property, where we take each of these factors, we set them equal to 0, and we solve them. This one over here, we'll add 16 to both sides. And then don't forget we've got this x squared term here. We need to get rid of that power of 2 by square rooting. And remember, that means we need to do plus or minus, leaving us with plus or minus square root of 16 is 4. So we've got plus or minus 4 from that factor. Solving this one, looks like we're going to have plus or minus square root of 2, which we can't really break down any further. So our final answers are 4, -4, square root 2, and negative square root of 2. 4 answers for that one. And it looks like that's A, plus or minus 4, plus or minus square root of 2. Okay. Number 5, I marked this one as one of my gimme problems, right? These shouldn't be too difficult, as long as we remember what domain is and what range. And we should remember that domain for these parabolas, always negative infinity to infinity. The domain of a parabola, at least the ones we're coming across here in class, always negative infinity to infinity. So right away, this domain is not negative infinity to infinity, and neither is this one. I'm eliminating those from my answer choices because I know the domain is negative infinity to infinity, so it has to be either A or B. Now the range is asking us, how low does the graph go? Well, that should be easy to see. It's going down forever, so that's negative infinity. And then how high does it go? What's the highest point of this graph? What's the peak? The peak is right here at -2. So we know we go to a low value of negative infinity, high value of -2 for our range. And the only answer that has that is B. Number 6, f of -2. This is where they're giving us the x value, right? They're saying, hey, x is -2. So we can find -2 on the x-axis, which is right there. So if we kind of put our cursor there, then we ask ourselves, are we on the graph? If not, we need to move up or down to hit our actual graph. But in this particular case, we're sitting on the graph, right? We're sitting on this line here already. So we're ready to determine the y value. We can just trace over to the y-axis and we hit at 0. So when x is -2, we're actually on our graph for a y value of 0. Number 7, identifying the vertex and then determining the minimum or maximum of the function. Well, knowing what we know about parabolas, we should know that this is a happy face parabola, right? Because there's not a negative in front. So I know this parabola is going to look like a happy face, which means it has a minimum value, right? The vertex is a minimum. It goes up forever, so there is no maximum. And this point here is called the vertex, right? And that is the point hk, which we get right from these values in the function. They gave us this function in vertex form. So remember, for the x value of the vertex, we always use the opposite sign to what we see inside the parentheses. So we're going to use a +5. And the y value is the same sign, so that's going to be a -4 for our vertex there. So we have a vertex at +5, -4. We know we have a minimum value, and the minimum value is always the y value. That's what they're asking for. So these guys here, this is the y value. Well, I only see, nope, there are two answers. We can eliminate B, right? That doesn't have the right vertex. We can eliminate C, not the right vertex. A and D both have a vertex of 5, -4, but only one of them has a minimum. And we know this parabola, since it's a happy face, has a minimum. So it's got to be this guy, which is D. The minimum is -4. Or maybe I should say y equals -4. Okay. Number 8. This should be another, yeah, this is a gimme. As long as you have those transformation notes in your cheat sheet, which you should, this one shouldn't be too bad. From transformations, we need to remember that numbers being added or subtracted inside of parentheses or within the function, that moves our graph left or right, and it's kind of the opposite of what you would think. This +2 is going to move our graph left. It's going to move our graph left too. Okay, and then a number that's added or subtracted on the outside of the function, just tacked onto the end there, that moves your graph up and down. It transforms your graph up or down. If it's positive, it goes up. So this is going to go up 3. And then, of course, we know if we have a negative sign in front, that means we're dealing with a sad face parabola. So we're looking for a parabola that's a sad face and has been moved from the center left 2 and up 3. And there's only one graph here that matches that. Left from the center, left 2, up 3. And yeah, that puts us right at our vertex. So C is the answer in this case. Now, for sure this is a gimme problem. Even if you didn't remember your transformations, but you're using a graphing calculator like I have to the left here, you can plug this in your calculator. You know, you can go to y equals, and you can check yourself, make sure that you have chosen the right answer. I'm going to hit graph, and yeah, it looks like that matches pretty well to what we picked here. So we're golden there. Okay, so don't miss a problem like number 8. sketch the function and determine the axis of symmetry. Again, this should be really a gimme problem, especially with a graphing calculator. In fact, I think I might just type this into my calculator for this problem. But I'll talk about the transformations as I go here. So I'm looking for a graph here that's been moved to the right 2, up 4. It's an sad face, right 2 and up 4. Sad face, right 2 and up 4. It's got to be A, right 2, up 4. Okay, so A for that one. And I'll go ahead and mark these as well, these translations. Right 2, up 4, and then sad face because of that negative. And let's look at 10. Ooh, can I fit that on the screen? So we've got a model rocket that's launched from a raised platform at a speed of 192 feet per second. And they give us this height equation. And they want to know after how many seconds does the object reach its maximum height. As soon as I see the words maximum or minimum, I'm thinking of the word vertex. They must want the vertex. So we've got to know the vertex formula. And that's this here, negative b over 2a. That gets us the x value, which is often the time value. And then if we were to plug that value back into our function, we would get our y value of the vertex, which is often the height for these problems. But in this case, they're just asking for the time, right? After how many seconds does the object reach its maximum height? So they're looking for the x value of the vertex, which is the easiest part to solve. We just got to do this right here, negative b over 2a. Well, let me write out the height equation they give us. We've got b is 176. A is negative 16. And C is 20, but we're not even going to need to use C because, again, we're just doing this piece here. Negative b over 2a. So let's do that. Negative b over 2 times a. B is 176. A is negative 16. I'm just going to go to my calculator here. .5. So the x value of our vertex, or the time it takes to hit the maximum peak value, is 5.5 seconds, which corresponds to answer choice A. So again, if you see the words maximum height or minimum, you're looking for the vertex. That should scream vertex to you. Number 11 asks us to find the zeros of the function and state the multiplicities. I marked this one as a gimme problem as well because our answers are really right in front of us. We've got our 3 factors here, and they're asking for the zeros, which should cue us that we need to set our factors equal to 0 and solve. Right? This is kind of the zero factor property. So if we solve each of these, on this guy we just need to divide both sides by 3. right? 3 divided by 3 is 1. That leaves us with x equals 0. For this guy, we're just subtracting 9 from both sides. We're just doing the opposite. X equals negative 9. On this one, of course, we add 6. So we've got our zeros of 0, negative 9, and positive 6. How do we get the multiplicities? The multiplicities come from the exponents that were on each of those factors. So this factor had a multiplicity of 5. So 0 with a multiplicity of 5. Negative 9 came from here, so that's a multiplicity of 2. And 6 with a multiplicity of 5. Now, which answer corresponds? Everyone be really careful. Make sure we're really reading these answer choices. 0 multiplicity 5, negative 9 multiplicity 2, 6 multiplicity 5. Yeah, it looks like B is the answer here. Okay. And number 12, we're sketching this graph using transformations. Again, we could type this into our graphing calculator. That would be one way, but I remember that if we tack a number onto the end of our function, notice it's not inside the square root. It's not within the function. It's tacked onto the end. That's going to move our graph down 3 in this case because it's a minus 3. So we're looking for the square root graph, except it's been moved down 3, so it should look something like that. And it looks like that's this guy down here. So that's D. Again, if we wanted to, we could go to our calculator, our graphing calculator, go to y equals and type this in. We want to make sure we type it correctly though, square root of x, and then bump out using the right arrow key minus 3. And yeah, that looks pretty similar to the answer choice that we chose. Okay, so that was number 12. And I think I'll end it there. That way I can make these videos a little shorter. But I'll pick this up in another video.